So now to identify the apical vertebra, what we will have to do is to identify the vertebra that is farthest away from the central sacral vertical line. So now, to identify that, what you'll have to do is to be 100% sure that your measurements are correct. Now, this is the edge of the vertebra. Again, this is another edge of the vertebra below. And these are the farthest away vertebrae. So from this line, what we'll have to do is to draw a perpendicular line based on the central sacral vertical line, perpendicular to the central sacral vertical line. As you see here, it's a 0. And that goes to the edge of the vertebra, and measure the length of that line. Again, do the same for the other vertebra. And the one which is longer is representing the vertebra correspond to the vertebra that is farthest away from the central sacral vertical line, and thus the apical vertebra. Or what we can do, and we usually do, is we draw a line that should be vertical, so perpendicular to the horizontal, and then what we will have to do next is to bring it closer from the convex side of the curve to the vertebrae, and the first vertebra to touch this line is the apical vertebra. So here, this is the first vertebra that touched this line. Again, so this is the line, and this is the first vertebra that touched this line. Now, for that reason, this is the apical vertebra. Sometimes the line touches the area between two vertebrae, so the intervertebral disc, and if that happens, then what we will call this is the apex comes at the intervertebral junction between this and that vertebrae. So based on our identification, the apical vertebra is, so this is T12, T11, T10, T9, T8. So this is the apical vertebra. Again, it's a T8. T8. So T8 is the apical vertebra. So based on these parameters, only these parameters, what we can say is, up until now, that we have a patient with a right thoracic curve. Right, because you'll have to identify the direction of the convexity of that curve, and thoracic because the apical vertebra is T8. So this identifies the shifting of the spine at the thoracic region. This line, we have drawn it and used it to identify the apical vertebra. Now, next is to identify the Cobb angle. To identify the Cobb angle, you'll have to identify the end vertebrae. And to identify the end vertebrae, what you have to do is to identify the most tilted vertebrae, because this is the definition of an end vertebra. So to identify the tilting of a vertebra, what you'll have to do is to draw a line. To be specific and to be precise, you'll have to draw a line that touches the end plate of a vertebra, and then another line that is horizontal. Again, this line is horizontal, and this line is touching the superior end plate of the vertebra. This is the angle of tilting. Next, so this way we have measured the tilting of this vertebra. And then what we'll have to do is to draw another one here, and this is the line of the horizontal. Measure this angle and this angle and identify which one is bigger. So here is our measurement, and the angle here is almost 20, and the angle here is 25. So this angle is the tilting of this vertebra is more than the tilting of this vertebra, so we will use this vertebra as the end vertebra, this one. And now let's draw a line identifying our end vertebra. We'll change the color. Let's just get rid of this line that we have used to identify the apical vertebra. And again, we do the same process to identify the end vertebra from below of this thoracic curve. Now, if you're not quite sure, then you'll have to draw several lines for several vertebrae to identify the apical or the most tilted vertebra. So this is the line, and this is the most tilted vertebra. Now, in this scenario, I can actually, I don't need to go any further in identifying the cup angle, because now these two curves or these two lines have touched each other and an angle has been performed between them, and now I can measure the cup angle here. And it is 55 degree. So this is a massive degree, by the way. So it's a 55 degree of a cup angle. Now, let's add that to our definition, identification of the curve. So we have right thoracic curve, end vertebrae from, so this is 7, 6, 5, from T5 down to T11, with an apical vertebra of T8 measuring 55 degrees. So we are adding more and more to a proper identification of what can we see. So these are the most relevant and important and first step in identifying a curve, a scoliotic curve. Now, as a start, that is it, but in our next video, we will be explaining what we see here at the lumbar region and how can we identify two curves from one curve and what is an actual definition of a curve. And then we will go for drawing the or identifying the rotation, the stable vertebra, the neutral vertebra, and some other parameters related to the alignment of the spine. Again, Riser sign, we've talked a lot about it, and you've been taught how to measure it. Now we do have the pelvis here, and we can see the apophysis and the ossification. So what you'll have to do is to draw your line to separate it to the equal areas, and then identify the ossification limits, and based on that I give it a number representing a maturation.